Welcome to Episode 58, Cost Management Terms and Dashboards. The path to responsible cloud spending begins with visibility, seeing where costs originate, understanding what drives them, and then optimizing accordingly. Without clear insight, even sophisticated architectures can produce unpredictable invoices. Google Cloud provides a comprehensive cost management suite that translates complex billing data into actionable intelligence. Dashboards, reports, and metrics allow organizations to monitor consumption, identify inefficiencies, and align spending with business goals. Whether for executives tracking budgets or engineers tuning workloads, the goal is the same: clarity. When cost visibility becomes part of daily operations, financial control evolves from periodic review into continuous awareness, ensuring that every dollar spent contributes directly to measurable value.
Before interpreting dashboards, it helps to master key cost management terms. Usage represents the quantity of resources consumed, such as compute hours, storage gigabytes, or network traffic. Rate refers to the price applied per unit of usage, which can vary by region, service, or commitment level. Effective price averages all discounts and credits over total consumption, reflecting the true cost per unit after adjustments. For instance, if a team runs virtual machines under a long-term commitment, the effective price drops compared to on-demand rates. Understanding these definitions transforms raw billing data into meaningful insight. It reveals not just how much is being spent, but how efficiently those resources are being purchased and utilized across the organization.
Amortized versus list cost views show different financial perspectives of the same consumption. List cost represents what would have been paid at standard, on-demand pricing with no commitments or discounts. Amortized cost distributes prepayments and commitments, such as sustained use or reserved capacity, across the billing period, showing the real economic impact. For example, a one-year compute reservation appears as a smaller daily amortized expense rather than a single upfront charge. Comparing both views helps finance teams reconcile budgets while giving engineers accurate signals about operational efficiency. The distinction ensures decisions reflect total ownership cost, not just nominal list pricing. Breakdowns by service, project, label, and folder allow analysis at any organizational depth. Service-level reports show which products, like BigQuery, Compute Engine, or Cloud Storage, consume the most budget. Project-level views assign accountability to teams, while labels further refine attribution to specific environments or initiatives. Folders group related projects, offering aggregated visibility for departments or product lines. For example, a marketing folder might include analytics, content delivery, and advertising workloads under one cost summary. This hierarchy transforms billing into a management tool that mirrors the structure of the business, enabling granular accountability and more accurate forecasting across the organization. Dashboards serve different audiences but share the same goal: making data actionable. Executive dashboards emphasize trends, forecasts, and high-level summaries, enabling quick strategic decisions. Engineering dashboards focus on operational details like resource usage, efficiency ratios, and cost per service. Both derive from the same billing data but present it through lenses tailored to their users. For instance, executives might track monthly spend against budget targets, while engineers monitor daily compute hours to prevent inefficiencies. Well-designed dashboards create a common language between finance and technology, ensuring that all stakeholders see costs not as isolated figures but as indicators of performance and value. Heat maps help visualize cost anomalies and usage spikes over time. They transform raw numbers into color-coded patterns that reveal when and where consumption deviates from expectations. A sudden spike in compute spend or network egress might appear as a bright area, prompting investigation. For example, an unexpected data export could indicate misconfiguration or unplanned workload scaling. Heat maps allow teams to spot inefficiencies quickly, turning visual cues into investigative prompts. Regularly reviewing these patterns builds intuition for what normal looks like, enabling faster recognition of emerging issues before they compound into significant budget impacts. Right-sizing recommendations guide users toward optimal resource allocation by analyzing utilization data. Google Cloud's cost tools can suggest smaller machine types, lower reserved capacity, or schedules that automatically shut down idle instances.
For example, if a virtual machine consistently uses only 30% of its capacity, a recommendation might propose a smaller instance, reducing both cost and waste. Automating these changes ensures continuous alignment between resource supply and workload demand. Combined with scheduled start and stop policies, right-sizing minimizes waste without compromising performance. Over time, this process becomes a self-correcting loop, steadily improving efficiency through data-driven adjustments. Idle resource detection and cleanup address one of the most common sources of waste: forgotten or underused assets. These might include unattached storage volumes, inactive instances, or outdated snapshots. Google Cloud's Recommender service identifies these resources and estimates potential savings from removal. For instance, deleting unused disks from terminated virtual machines can instantly reduce recurring costs. Automating cleanup through scripts or lifecycle policies keeps environments tidy and budgets lean. Regular attention to idle resources not only cuts expense, but also strengthens security posture by reducing attack surface and operational clutter. Efficiency, in this context, supports both financial and technical hygiene. Storage class shifts and lifecycle moves extend optimization into long-term data management. Not all data requires high-performance storage indefinitely. Google Cloud Storage offers multiple classes, from standard to nearline, cold line, and archive, each suited to different access frequencies. Lifecycle rules can automatically transition objects to cheaper classes after a set period. For example, logs older than 90 days might move from standard to cold line storage, cutting costs dramatically while preserving availability when needed. These automated transitions ensure that storage expenses align with actual usage patterns, turning data retention from a static cost into a dynamic, policy-driven optimization process. Network egress analysis reveals how data transfer choices influence cost. Egress refers to data leaving Google's network, whether to the internet, another region, or a different cloud. Costs vary depending on destination and volume. Dashboards can display egress by service, region, or project, highlighting patterns that drive expense. For example, replicating large data sets across continents might provide resilience but incur significant fees. Teams can adjust routing strategies or use content delivery networks to localize traffic and reduce distance-based charges. Understanding egress behavior enables smarter architectural decisions, balancing performance with predictable network spend. Reservations utilization and commitment coverage metrics help ensure that cost-saving agreements deliver their intended value. Underutilized commitments mean wasted potential savings, while overcommitment risks inflexibility. Dashboards show actual usage versus committed amounts, helping teams fine-tune their portfolio. For instance, if compute usage consistently falls below commitment levels, reallocating or resizing reservations can recover efficiency. Monitoring these metrics prevents discount programs from turning into hidden inefficiencies. When commitments align closely with real consumption, organizations achieve both financial predictability and operational agility. Chargeback and showback models operationalize accountability for cost across teams. Showback provides visibility, reporting, usage, and spend without direct billing, while chargeback allocates actual costs to departments or product owners. Both models encourage responsibility and promote cost awareness at every level. For example, a chargeback model might bill each business unit for its compute and storage consumption, while showback reports create friendly competition around efficiency. Implementing these models requires clear tagging and governance, but the payoff is cultural. Teams learn to treat cloud resources as shared investments, not free utilities, reinforcing financial discipline across the organization. A monthly cadence of review, decision, and action ensures that cost management remains an active practice. Each month, teams review dashboards, discuss trends, decide on optimizations, and implement corrective steps. This rhythm prevents surprises and builds shared accountability between engineering and finance. For example, a monthly meeting might identify an upward storage trend and trigger lifecycle policy updates to reduce expense. Regular reviews create predictability and embed cost awareness into operations. Over time, this cadence transforms financial governance from an afterthought into an integral part of performance management and planning. Clarity drives responsible spending, the ultimate lesson of cloud cost management. When organizations can see clearly, they can act decisively. Dashboards and analytics are not ends in themselves, but tools for aligning decisions with strategy. Google Cloud's cost management capabilities make every expense traceable, every anomaly visible, and every optimization measurable. Transparency fosters accountability, and accountability fosters efficiency. By combining clear metrics, automation, and regular communication, teams achieve sustainable growth where financial discipline supports, not limits, innovation. Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.